If you need more time to draw our unit circle outline, would you please click the raise hand button? If you need more time, will you please click the raise hand button? It's on the bottom by like where you turn your microphone and camera off in that bar, if you're unsure where that is. Got it. Thank you, Jermaine. Thank you, Max. Okay. All right, I'll give you another 2 minutes or so. And then we'll start talking through this. So if you are finished drawing the unit circle, I would recommend doing your best to fill in some of the things that you can, if possible. All right. So hopefully you have that all filled in by now, or well, not necessarily filled in, but at least created with these blanks. So there are really 3 types of things we need. We need our angles in degrees. That's everything with this degree sign. We need our angles in radians, and then we need our terminal points. So remember, the unit circle is a circle that exists in the Cartesian coordinate plane, so the XY plane, where just the distance from the origin to all of these terminal points is a distance of 1. So with your lesson on Monday, we talked through how those points were created using right triangles, where the hypotenuse, or the distance from the origin to that point, is 1. And these points represent the x and y values. So it's just the x and y value of this point. And the value of the unit circle is it allows us to work with sine, cosine, and tangent, so trig functions, in a much quicker way. And it allows us to easily apply those trig functions to our special angles if we have a quick knowledge of the unit circle. So anything related to triangles, the unit circle comes in handy, as well as anything that has any sort of like wave-like structure. So things like sound have wave-like structures, and the way that we The functions that define these are trigonometric functions, so like sine and cosine. We'll spend more time with things like that next unit, so next semester. But that's where we'll see some more application, particularly for the unit circle. So as we focus this unit, you may not see a lot of real world application or the value of the unit circle, but we have to start somewhere. We have to start with defining it and developing this system so that we have it, and then we can then apply it as we continue into our next units in the next semester. So it may not seem very valuable as we're going through, especially with this unit, but trust me, it is very important. If you want to do anything or that involves math, physics, engineering, anything related to those fields, the unit circle is one of your best friends. It's very, very important. So let's talk through filling it in and helping us to remember these key points angles in both degrees and radians. So the key to filling this in and remembering them is recognizing patterns. How things increase with your degrees and radians, the different options for terminal points. So I'm going to outline the way that I think through the unit circle and the patterns that I have noticed. If you notice other patterns, that's great. You're welcome to latch onto those. But these are the patterns that I see, or the things that help me remember the degrees, radians, and points in our unit circle. So we'll start by filling in our degrees. So a couple things to note. Number one, there are a few degrees that I would consider the easy degrees. So on that positive x-axis, we have 0 degrees. On the positive y, we know this is 90 degrees. Over on the negative x, we have 180 degrees. Negative y, we have 270. And we also have, you'll see this written as well as, so like 0/360 degrees as well. So that's how we define those first 4, or at least that's where I start. The rest of the way, I just think in terms of addition. So if you recall, our unit circle is constructed by using 30, 60, 90 triangles and 45, 45, 90 triangles, where these angles are 30, 45, and 60. But one way we can calculate these is through addition. So one trend that I notice is every other key angle on the unit circle is a difference of 45 degrees. So from 0, we skip 1 to here. This is that 45, 45, 90 triangle, that special triangle that we work with. If I add 45 again, I get to 90 at the top. I add 45 again, 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270 at the bottom. And 270 plus 45 is 315. And 315 plus 45 is 360. So one way to calculate those middle angles is by just adding 45 degrees. And we can do the same by going by either 15s or 30s to figure out the rest. So a couple ways to think about these. So with these special triangles, we have a 30, 60, 90 here. So this is 30 degrees, 45, and 60. You may have noticed that the difference between our other key angles and our 45 degree is a difference of 15. So with this angle being 30, 30 plus 15 is 45, 45 plus 15 is 60. And you could apply that same rule over here in quadrant 2. 15 degrees less than 135 is 120. 15 degrees greater than 125 or 135 is 150. So there's a 15-degree difference always between those. A different way to think about it is you can go by 30s by incorporating also our axis angles. So 0, 90, 180, and 270. You'll notice from 0 to 30, we add 30. Skip over your 45-degree type angles. Plus 30 is 60. Plus 30 is 90. Plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210. 210 plus 30, 240. 240 plus 30 is 270. 270 plus 30, 300. 300 plus 30, 330. And 330 plus 30 is 360. A couple ways to think through that. So you can think in terms of like adding or subtracting 15 from that 45-degree type angles, the ones in the middle, or you can add 30 to each all the way around. So these are all of our key angles, and all these are the key angles because they're all 30, 60, 90 or 45, 45, 90 type triangles. That's where they all come from. They're just those triangles in different spots on the unit circle. So like this 150 here, we have another 30, 60, 90 triangle, just in a different quadrant. So they're all the same types of angles, just different quadrants. So next, last one, we have our radians. So again, the way that I start with my radians is I first think in terms of these axis angles. So we have 0 or 0 pi, you could think of really just 0. 0 radians there. 90 degrees is the same as pi over 2. 180 is pi. So the difference between each of these is a difference of pi over 2. 270 is 3 pi over 2. And back to 360. 360 is 2 pi. So if we think in terms of 45s and 30s, like we did in degrees, the equivalent in radians, like if I were to convert to radians, would be pi over 4 and pi over 6. So in the same way that we added 45 to get to each of those middle angles, to those same angles in radians, we can just add pi over 4. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4. So if I were to, so I'm in the bottom left right now. If I were to add those together, so we'd have to think in terms of common denominators, combining fractions. So pi over 4 plus pi over 4 would be 2 pi over 4, which simplifies to pi over 2. But we have 0 pi over 4 plus 1 pi over 4. Another 1 pi over 4 is 2 pi over 4. Another pi over 4 is 3 pi over 4. Plus pi over 4 is 4 pi over 4, or just pi. Plus pi over 4 is 5 pi over 4. Plus pi over 4 is 6 pi over 4, or 3 pi over 2 simplified. Plus pi over 4 is 7, because we go from 6 to 7, pi over 4. And then here we have plus pi over 4 is 2 pi. So we can find those radians by adding pi over 4 on those 45-degree angles. In the same way that we went by 30s, or one way we did that was to go by 30s, we can do the same here. So all those missing angles, so all these non-45s really, or non-pi over 4s, we can just add pi over 6. So 0 plus pi over 6 is 1 pi over 6. Plus pi over 6 is 2 pi over 6. which simplifies to pi over 3. Plus pi over 6 is pi over 2, plus pi over 6. So pi over 2 is our 3 pi over 6. Another pi over 6 would give us 4 pi over 6. So we're just adding pi over 6. So 4 pi over 6 would simplify to 2 pi over 3. Four pi over 6 plus pi over 6 would give us 5 pi over 6. Plus again would give us 6 pi over 6, which is pi. Plus again would give us 7 pi over 6. So we're just counting up by pi over 6's. So 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7, 8 pi over 6, which is a fraction that simplifies to 4 pi over 3. So 8 over 6 simplifies to 4 over 3. That's what I'm doing there. 9 pi over 6 is 3 pi over 2. 10 pi over 6. So 10 over 6 simplifies to 5 over 3. So we have 5 pi over 3. Plus pi over 6. So 10 plus 1 is 11. So I get 11 pi over 6 there. You could theoretically take all of these degrees and just multiply by pi over 180, convert to radians that way. But I think it is easier to if you're able to remember those key values like that. Okay, so that's our radians degree, or our radian angle. The last thing we have is our terminal points. So again, on the axes, that's usually our easiest place to start. So here, again, it's just an x and y plane. So over here would be a distance of 1. So our point would just be 1, 0. On our positive y-axis, our point would be 0, 1. Negative x, our point would be negative 1, 0. And our negative y would be 0, negative 1. So I know that it's all 1 because it's the unit circle. The distance from the origin to all of these points is a distance of 1. And we're just going directly on our axes. So we can't have an x or a y value accordingly if it's on the opposite axis. The rest, the way that we think about these. So on Monday, I showed you how we come up with these values by using those special triangles. So there's a couple ways I think through these. So the easy ones for me are obviously these axes. With all of these other terminal points, I know it's always some combination of these 3 fractions. So 1/2, root 2 over 2, and root 3 over 2. So one thing that I know is that my 45-degree angles, really if you're able to know or to notice the this first quadrant, you can apply it to the rest. The way that I think through this, and I will show you a different way to think about it using, it's called the left-hand trick next. But the way that I just remember is I know that 45 type angles are always root 2 over 2, root 2 over 2. That's just something that's easy for me to remember. 45, 45, 90, always have those same root 2 over 2 over and root 2 over 2. That's my x and y value at this point. And our 1/2 and root 3 over 2, I know that those just go with pi over 6 and pi over 3. And they have to be in some different order. The way that I think about it is by using triangles. So I know the square root of 3 over 2 is larger than 1/2. So if I think about this point here and think about the triangle it creates, so I'll try not to run into those other points. And I just look at the x and y value of the triangle. So the x just being this bottom side, the y being this side, because we're thinking about this point as an x and y value. I know the x side of this triangle is larger than y. So that tells me the x value at pi over 6 has to be root 3 over 2 instead of 1/2. It has to be the larger of the two. 2, and the y value has to be 1/2. In the same way with root 3 or pi over 3, my x value here, so if I'm thinking about this point, x up to y, my x value is going to be less than my y value. So I know the x value of this point has to be less than the y value. So my x has to be 1/2 and my y has to be root 3 over 2. So the way that I remember these is I just remember that 45 type angles are always root 2 over 2, root 2 over 2. And you have to remember those 3 points or these 3 values of 1/2, root 2 over 2, and root 3 over 2. And then I think in terms of triangles to determine those other two. Which one has 1/2 first, which one has root 3 over 2 first. And the way that we construct all these other points is by using these 3 and thinking about what quadrants we are in. So if we think about quadrant 2, just thinking about general x and y values in terms of positive and negative. In quadrant 2, we are on the negative x-axis and positive y. So all of these points are just going to be mirrored the same, but with different signs, or with the according signs. So like here, my middle angle at root 2 over 2, root 2 over 2. Again, it's another 45 type angle is what I call that middle angle because it creates a 45, 45, 90 triangle, just in a different quadrant. So it's going to have the same terminal point, but instead of being root 2 over 2, root 2 over 2, it's going to be negative root 2 over 2, positive root 2 over 2. Same with over here. Again, this is another 60, 30, 90 triangle. It's the same location here as pi over 3. So instead of being 1/2 root 3 over 2, it's just going to be negative 1/2 root 3 over 2. So it's the same terminal points as this first quadrant. You just change the signs because you're in a different quadrant. So over here, we'd have negative root 3 over 2, positive 1/2. And the same idea would apply to these other quadrants in 3 and 4. So with quadrant 3, we have a negative x and negative y. So here, down below, mirrors. So we have, right here, we have a 30, 60, 90. So a longer x than y. So I know it's going to be the same first point here, but just both have to be negative. So it'll be negative root 3 over 2, negative 1/2. For 5 pi over 4, it's a 45-degree type angle. So it'll be negative root 2 over 2, negative root 2 over 2. So again, the same as the corresponding, just match the signs because they both have to be negative here. And you'll see that those points, at least in the negative y-axis, may be hard to tell. They match up along a line here as well. So root 3 over 2, 1/2, negative root 3 over 2, negative 1/2. So you can see that too if you're unsure of which goes with which. And then last we have 1/2 root 3 over 2, but they both have to be negative. So we have negative 1/2, negative root 3 over 2. Lastly, quadrant 4. In quadrant 4, we are positive in the x, negative in the y. But those terminal points will be the same. You just have to match up the correct signs. So here, 11 pi over 6 goes with negative root 3 over 2, 1/2. But instead, our x value has to be positive, so it's got to be positive root 3 over 2. Our y value has to be negative. Same within the middle. Middle one is always root 2 over 2, root 2 over 2. You just have to match up the correct signs. And 5 pi over 3 is going to be positive 1/2, negative root 3 over 2. There are other patterns you may see that may be helpful, like everything that's over 4 has the same terminal point, just different signs. Everything that's listed as over 6 in radians has the same terminal point, just different signs, and everything that's listed as over 3 is the same. So you may be able to make those connections in that way. There are lots of patterns because it's all just constructed basically from this first quadrant. And it's just a recreation in different quadrants of those same triangles. So there are lots of patterns that you may see that may help you to remember these. Questions on anything we did there? So I know I walked through kind of in a similar way on Monday, so hopefully you saw that then. But I tried to emphasize these patterns a little bit more as we're talking through. The next thing I want to do is I just want to show a quick video that has been helpful for students in the past with remembering these terminal points. If it confuses you, ignore it. You don't have to go by this video, but for some it may be helpful, which is why I would like to show it. Wow, that looks kind of crazy. All right.
Hi, you guys. It's Mrs. Pruitt Britton again, and I wanted to do another quick lesson on how to memorize the unit circle coordinates. And this time I'm going to use the left-hand trick. You can use this if you like. If you don't like it, you don't have to use it. All right, so you can look at the palm of your left hand. And I want you to think about is the first quadrant of our unit circle. I'm drawing this hand right here. Let's say that's my first quadrant, right? Then this would be at 0 degrees. This next angle then would be 30 degrees. The next one would be 45 degrees, 60 degrees, and then of course the 90 degrees, right? So when I'm talking about this trick and what you can do using your fingers, that's what I'm going to be referring to. And that's where I'm getting it from. It's from the first quadrant of the unit circle. So let's take all these away. All right, now I got my hand back. I'm just going to write on my fingers, and no, you cannot do this during class. I'm going to write 0 degrees, 30 degrees. I always get stuck. 45 degrees, 60 degrees, and 90 degrees. You can always put radians to 0, pi over 6, pi over 4, pi over 3, and pi over 2. So what will help you to memorize the coordinates of the left and the right hand side when I'm talking about the coordinates? I'm talking about that, your ordered pair. Whatever number that we get by putting down whatever finger of the degree that we're looking at, I'm going to take our number of fingers and we're going to put that underneath the square root and divide it by 2, and that will give me my answer. So let's do an example really quick. So let's say I want to find the first coordinate for 30 degrees. So I would put this finger down. Put that finger down. And what does that give you on the left-hand side? Well, I have 3 fingers there. 3 fingers is what will go underneath here. So this answer is the square root of 3 over 2. And the right-hand side is going to be how many fingers I have over there, which is 1. So then I'm going to put the square root of 1 divided by 2. And of course, the square root of 1 is 1. So that really is just 1/2. Boom. That's the answer for 30 degrees. All right, so let's say that we wanted to do this for the 45-degree angle. So I would actually put this finger down and then look at the numbers that I have on the left and the right. On the left here, I have 2 fingers. So on the left here, my coordinate, my ordered pair, is going to be square root of 2 over 2. Over here, I have 2 fingers. Again, it's going to be 2 underneath the radical here. So my answer is going to be square root of 2 over 2. Let's do 60 degrees. I will put this finger down. And then I would look to see how many fingers do I have on the left. I have 1. So this is going to be square root of 1, which is 1 over 2. And on this side, I have 3 fingers. So it would be 3 that will go underneath my square root. And that's what's going to be the answer. It even works for 0 and 90 degrees. So in this case, I want to know what are the x and y coordinates for 0 degrees. Well, I put that pinky finger down, and I have 4 fingers on the left. So I'm going to put a 4 under there, where the square root of 4 is 2, right? This is 2 divided by 2, which is just 1. So 1 goes over here. Notice there are no fingers on this side of my pinky, hopefully, for most of us. So its right-hand side is going to be 0, or my y coordinate value will be 0. Last but not least, the 90 degree. I'll put my thumb down, and then I'll check out what I have. Well, on the left, there's nothing there. Square root of 0 is 0. 0 divided by 2 is 0. So it's going to be 0. And since I have 4 fingers left on my right-hand side of my thumb that I put down, my 4 will go under here, just like we just did. The square root of 4 is 2, and 2 divided by 2 is 1. So I know that its ordered pair will be 1. All right, you guys, so now that I know how to use my hand trick, I can really just fill in on the rest of my unit circle. All I really need to remember is that on this side, it's going to be positive, positive. On this side, it's going to be negative, positive. In this quadrant, it's going to be negative, negative. And in this quadrant, it's going to be positive, negative. So one last example, again, let's say I'm working with a 30-degree angle. I'll put that finger down, and then I notice that I have 3 on the left. So here, this would be the square root of 3. And on the right, I have 1 finger, so it's 1/2. So it's the same answer over here, except it's going to be negative, positive. So it's negative square root of 3 over 2, 1/2. Negative square root of 3 over 2, and negative 1/2. And over here, it's going to be positive root 3 over 2 and negative 1/2. Hope you guys can see that. And I hope that this helps some of you guys who are still having problems memorizing the unit circle.
All right. So that only really covers our terminal points, which tend to be the most challenging, at least from what I've seen for students. And this trick is really valuable for that first quadrant, and then you have to just match things up to quadrants 2, 3, and 4. You can't really like reorient your hand and do the same thing. There are ways to do it, but you have to like change. It's easy in the first quadrant because like the left is the X, the right is the Y. When you get into other quadrants, it gets a little bit trickier. So I would recommend just focusing on that first and then trying to match things up into 2, 3, and 4. Okay. So,
Hi, you guys.
come on. All right. We have about 8 minutes left. So what I'm going to do is I'm going to post a couple of these unit circle practice games into our chat that we can try. This will be some good practice for identifying, remembering those key angles as well as terminal points. So this first one I'll walk through briefly, just kind of show you what you're doing. So you click start game. This one, it's going to include, like, you're given all the degrees, but it's going to show up with radians, with terminal points, as well as where is it, like positive, 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 negative. So your quadrants. So I clicked there. So 7 pi over 4, what I have to do, determine which one of these is 7 pi over 4. So you pick the right one, it tells you you're green. When it gives you a point, you pick the thing in parentheses. So 1, 0 would be an x value of 1, y value of 0. So we'd put that there. If this one is positive, negative, so positive, negative is quadrant 4. If I click the wrong one, so like let's say I pick this angle, it tells you, nope, you're wrong, try again. It tells you what it actually is. I click again, nope, you're wrong again. I guess it tells me to be patient and keep clicking. And then eventually it does tell me what the solution is. It's right there. I click it and it lets me move on to the next. So next I have like negative root 2 over 2, root 2 over 2. So I know it's negative, positive. So negative x, positive y would be quadrant 2. My root 2 over 2 types are my 45 degrees, so I put that there. So you can go ahead and keep doing that. Try and get a high score. Above 90% would be cool, and see how fast you can do that. This is something that when you finish, you'll have an option to restart, try again if you'd like to. Or you can stop it, start over if you want. So that's the first link I posted. I will post another as an example too. Basically the same idea, except with this one. So you're clicking those points as well. So like we have negative 1/2, negative root 2 over 2. So I got a little sound effect for it there. But it also requires you to put the degrees. So degrees would just be those points with the degree symbol. If you click wrong, again, it tells you you're wrong. This one, though, it doesn't tell you what it is until a little bit. It doesn't tell you what those wrong answers are, but eventually it does tell you where to put that correct answer. So same idea, just a little bit different format. This one asks for degrees as well. So I will post that one for you too. So we have about 5 minutes left. So I know it's not a lot of time, but I'd like for you to click one of those links, try one of those games, whichever one suits you. Play that for the next 5 minutes or so to try and get some practice with remembering. And if you could play that a few more times later today, just to revisit, get some quick practice. Maybe do it like once during advisory and once after school or something like that. Getting some of that repeated practice will be really valuable. I will post these links in our week at a glance in today's section as well, so that you have access to them there, because obviously this meet is going to close in a few minutes. Before you get started on a couple of those games, do we have any questions, either about these games, about the agenda, or about anything related to the unit circle? Okay, I'm not seeing any hands up or things in the chat, so I'm assuming we have no questions. Hopefully, things will start to stick a little bit better with the unit circle. The unit circle is not something that you look at once and then you've kind of got down. It does require a lot of practice and a lot of revisiting, so that eventually you can kind of implant it in your memory. So taking some time to just rewrite the whole unit circle, or practice with some of these games to try and remember those key angles and points will be really valuable. We'll be spending some more time in class with those things, but tomorrow we are going to start spending some time applying the unit circle, at least in a very small way. So you can anticipate that in a new set of notes for tomorrow. So as you're getting started on those games, if you would like to leave the meet at this point, you are welcome to. Have a great rest of your day.